In section 3, we are going to talk specifically about right triangle trigonometry and specifically Sohcahtoa. Now, Sohcahtoa gets at our three main trig ratios of sine, cosine, and tangent. Sine, cosine, and tangent. And we can always find these ratios. And again, if you remember, no matter what my size of my triangle is, 32-degree angle is going to have the same side ratio as every other 32-degree angle, no matter how big or small my triangle. And what is that ratio? So the sine ratio is opposite over hypotenuse. And the cosine ratio is the adjacent over hypotenuse, and the tangent ratio is the opposite over adjacent. Now, this brings back, just to remember, these two must always be less than 1. And if you think about that, the hypotenuse is your longest side. And so a small number divided by a big number is always less than 1. Tangent can be bigger or smaller than 1, just depends. Now, the other tricky part is the hypotenuse, always the hypotenuse, no matter where you are. Opposite and adjacent are relative to what angle you are discussing. So it all matters about what angle you want. So let's say we're going to pick this angle. We're going to call it theta, which is just a trig variable. So if I find my trig ratios for theta, then from theta, from right here, this side is opposite, and this side is adjacent. Adjacent means right next to. See, that side is right next to. Opposite literally means opposite. So if we talk about the sine of theta, that is opposite over hypotenuse, and so that would be b over c. We talk about the cosine of theta, that is adjacent over hypotenuse, so in this case would be a over c. And the tangent of theta is opposite over adjacent, b over a. But if I switched, I went over to this exact same triangle, but I moved up, and let's call it beta, this angle up here, a, based on that, hypotenuse is still the hypotenuse, but now this is my opposite, and this is my adjacent. So you're going to always see me circling and marking the angle that I'm working on so that I know exactly what is opposite and what is adjacent relative to where I'm at. So in this scenario, the sine of beta is a over c. The cosine of beta, adjacent, b over c. And the tangent of beta, opposite over adjacent, a over b. And you'll see some relationships between sine and cosine of the two different angles. That we will save for Algebra 2, but just notice there is a relationship. So always know exactly what angle you are working on. So in this example, the sine of x, the cosine of x, and the tangent of x, these directions want the ratio. Now we can use that inverse feature and we can actually get the angle out if we want. But if it says find sine of x, cosine of x, tangent of x, it wants the ratio. It wants opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So here is x. Hypotenuse is always hypotenuse. From x all the way across here is opposite, and this one that touches is the adjacent. So when I go to write the sine of x, opposite over adjacent, or opposite over hypotenuse, excuse me, 5 over 13. When I go to do the cosine of x, I am doing the adjacent over the hypotenuse, which is 12 over 13. And when I go to do the tangent of x, which is opposite over adjacent, I have 5 over 12. Those are your answers. As long as your fractions are reduced, that is all you need to do. Number 2 is a review problem of 30 60, 90, 45, 45, 90. So we're not going to spend time doing that right now. 3 and 4 are also special right triangle reviews, so we are going to skip those, and we are going to jump down to this example. Find the measures of angle E and angle F. So this is where our trig ratios, again, come in handy. If I want to know E, what sides do I know in relation to E? Well, hypotenuse is hypotenuse. Now 12 is adjacent to E. It is right next to you. So when I'm talking about adjacent and hypotenuse, I am talking about the cosine of E would be equal to 12 over 13. Now we know we can go to our calculators and we can use the inverse of 12 over 13 to find out what the measure of that angle is. So if we go to our calculator and we do 12 divided by 13, and then we do inverse cosine, we find out that this is a 22.6 degree angle. Now we could subtract from 180 to find F, or just for practice, let's see. So based on F, hypotenuse is still hypotenuse, but this becomes the opposite. So we're really looking at the sine of F is equal to 12 over 13. And if we take the inverse of that with our calculators, and go back to our calculator and we say clear, and we say 12 divided by 13, and we hit equal, and then we do inverse sine, we get a 63.4 degree angle. And now we can check. If we add 22.6 and 63.4 and 90, we better get 180. And in this case, it does work. So one more example, finding J and K. Similar sort of strategy. Again, based on J, this is my hypotenuse, always my hypotenuse, but from J's location, this is opposite. And so opposite and hypotenuse, I'm looking at the sine of J is equal to 9 over 11. That is going to be a fraction less than 1. When I go to my calculator and do the inverse, I find out that J is 55 degrees. Now, by simply subtracting, I know that K should be 35 degrees, but does it work out? From K, this becomes my adjacent. This is still hypotenuse, so I have the cosine of K is 9 over 11. When I go to my calculator, and I say 9 divided by 11, and I hit equal, and then I do inverse cosine, I get 35 degrees, just like I would expect, so that I can say 55 plus 35 plus 90 equals 180. So that is how you use Sohcahtoa with right triangles to find both angles and ratios of sides. It could be used to give you actual sides. You could set up a proportion and cross multiply, but most often we use it just to find the ratio and to find the angles. Good luck with your homework.